Hey guys, let's go ahead and finish 12.2. Let me bring up the PowerPoint and get to the right place. Okay, so here, we're going to talk about the regression model again, or the line of best fit, because the whole point of regression is to compare two variables to see if there's a model we can make to predict other instances that are very similar to that. So, a prediction of a regression model cannot be made if the data does not follow in a linear pattern when graphed on a scatter plot. And we saw that before. If you look at some data, it's all jumbled. There's no kind of anything going on. So that means if you don't see like a line that you could possibly link out, then it's not a good prediction, or excuse me, it's not a good regression model. The second one is their correlation coefficient is not statistically significant. We talked about that in the first part of chapter 12. It's the R alpha compared to the R. And then if you want to make a prediction outside the value of the range of the sample data, you can't do that either, because making predictions with regression models are very specific. And that goes on to the fourth one, that you can't make a prediction with a population that's very different from your sample. So let's keep going. Okay. So the last one we did, we showed the regression line was y equals 103.085 minus 1.043x. So can we predict test scores for 16, 19, 25, and 45? So how do you do that? Well, all you do is you plug in the number for x, and then you solve for y, just kind of like an algebra problem. And if you see for 16, a class size of 16, we're going to predict that the test score will be 86.397. For a class score size of 19, the score is going to be 83.268. And for a class size of 25, it's going to be 77.010. But let's look at that 45. We can't use 45 because that falls outside of our range of the original data. The data only went from 15 to 29, so you can't use 45 to predict it. So let's look at another example of this. So we're going to find the least squares regression line for the given data set. So here we're going to look at Land Rover Freelanders and their age in years. Find the regression model for predicting the price of a used Land Rover Freelander based on its age in years, if it's appropriate at the 0.05 level of significance. So here's the data. So first thing you're going to do is put it into your calculator. So remember, to do this, you're going to go stat, enter, and put age as your x and price as your y. So age will go in L1, price will go in L2. So if you want to, go ahead and pause the video and go ahead and put that in. Okay. And if you put it in, and here's the directions again if you need it, you're going to see at the results on the side the linear regression stuff that you get. So you get y equals ax plus b, where your slope, which is a, is negative 4,257.818182. Your y-intercept, which is your b, is 34,051.90909. Your r-squared is 0.745229, and your r is negative 0.863267. So, what we want to find out though is, before we even write that equation line, does there show that there's significant evidence for a linear relationship to exist? So let's do the scatter plot. And if we're looking at the scatter plot, yeah, we're seeing that there's a linear pattern. Look at that. It's decreasing, so that'd be a negative, but I can actually see where we put a line. So let's keep going. Okay, so now we have to see about the correlation coefficient so that we can do to see if there's significance. So remember that table I in the back of the book. You're going to figure out your n, and let's go back and look at n. So we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we had 10 sets of data, and then we had a significance level of 0.05. So if you go and look at the book, you're going to find your correlation coefficient of 0.632. So if we take the absolute value of R and get 0.863, that's greater than 0.632. So that's enough evidence at the 0.05 level to conclude there could possibly be a linear relationship between these two variables. So then we can write the regression line. So we go ahead and plug in A for slope and B for y-intercept, and this is what we get. We get y equals $34,051.909 minus 4,257.818. So what can we do with it? We could actually make predictions. So let's see the selling price. Okay, so A is the selling price of a Land Rover Freelander that is 2.5 years old. That's possible. The selling price for a Land Rover Freelander that is 10 years old. Well, we can't do that because remember, our data was only for 1 to 4 years. 10 years is outside of our range, so we cannot make a valid prediction using this model. C, the selling price of a Land Rover Range Rover that is 3 years old. Okay, we can't do that either because that's a different population than the Freelanders. And if you know, Range Rovers are a lot more expensive than Freelanders, so this would not be a good model. So the only one that we can use to do a prediction on is the first one. And if we substitute 2.5 years in, we get that the price would be $23,407.36. Okay, and again, the other ones you can't do. So there's the final problem on here for linear regression from start to finish, and it's talking about average temperatures and precipitation for 1 year in Key West. So go ahead and practice with this. The answers are always included in the PowerPoint and see how you do. This is how it usually goes in the real world and how we run a regression and how we analyze it. So let me know if you have any problems and take care.